Hello everyone and welcome to my video. Today I am excited to present my project on micro-own simulation which I have completed during the Embedded System Internship program. My name is Aditya Palode. I am third year AEP student at Government College of Engineering, Aurangabad. Before we get into the demo of my project, let me quickly share what I aim to achieve during this internship. The primary goal was to master C programming and understand difference between microcontroller and microprocessor. I also want to learn industry standard tools like MPLAB XIDE and Pixim Lab Simulator. And ultimately, the objective was to apply all of these to simulate a fully functional microwave oven using PIC16F877A microcontroller. Now, here is today's roadmap for video. We will start with fundamental of C programming, move on basic of embedded system, and finally we explore micro-own simulation project with live demo. Let's start with C programming. C programming is mid-level language known for its efficiency, portability, and flexibility. Referred as mother of programming languages, it allows us to structure programs as a series of functions which is initial for embedded system. During this internship, I covered key concepts like operator, arrays, pointers, functions, storage classes, preprocessors. First, we begin with operators. Operators are the symbols used to perform mathematical and logical operation on data sets. Some of operators are arithmetic operator, rational operator, logic operator, bitwise operator, assignment operator, and so on. Next, we look at arrays. An array is one of the most used data structure in C. It allows us to store fixed size collection of similar data items stored in continuous memory location. It can use to store collection of primitive data types such as int, char, float, and etc. Also derive and use defined data types such as pointers and structures. Then come to pointers. Pointers are one of the core components of C programming language. A pointer can be used to store memory address of other variable functions or even the other pointers. The use of pointer allow low memory access, dynamic memory allocation, and other functionality in C. Some key operators are address of, which retrieves the memory address of variable. Second, dereference access the value stored at address the pointer holds. Some common types are null pointer, void pointer, and smart pointer. Now, functions. A function is a set of statements in C programming that, when calls, perform for specific tasks. It is the basic of building blocks of C program that provide modularity and code reusability, which, which means we can write code once, use it multiple times. The programming statement of function are enclosed within curly braces having certain meaning and performing certain operations. The syntax of function can be divided into three accepts. First, function declaration. Second, function definition. Third, function call. Storage classes. In C programming, storage classes define the scope, lifetime, def- define value, and memory location of variables and functions. There are four primary storage classes in C. Automatic. It is the default storage class for local variables declared inside the function or block. Register to store variable in CPU register instead of RAM for fast access. Static. A static variable retains its value between function calls throughout the program executed. External. Used to give a reference to global variable that is visible to all program files. Finally, we come to preprocessor. Preprocessor are programs that process the source code before compilation. A number of steps are included or involved between writing program and executing in C or C++. You've probably seen hashtag include or hashtag define. These are directives that tell the compiler to include or define macros before the actual code runs. Now shift toward embedded system. Question is, what is embedded system? An embedded system is an integrated system that is formed as a combination of computer hardware and software for specific tasks. This may work independently or attached to larger systems to work on few specific functions. This embedded system can be work without human intervention or little human intervention. There are three main components of embedded system. First, hardware. Second, software. Third, firmware. Some applications are digital clock, elevator, washing machine, and also micro oven, and so on. This is here general block diagram of embedded system, which typically consists of input devices, processors, memory, and output devices. Embedded systems are classified into four main categories. They are classified based on performance and function requirement as well as the performance of microcontroller. First, real-time embedded system must produce output within defined time interval. Example, airbag system. Standalone embedded system function independently. Example, digital watches and calculators. Network embedded system connect to network to provide output to other systems. Example, home security and ATMs. Mobile and embedded system, small and portable devices. Example, smartphone, fitness tracker, and etc. Then a key question arises: what is difference between microcontroller and microprocessor? A specific application is essentially a single chip computer with CPU, RAM, and ROM with all in one chip, where microprocessor on other hand is general purpose computing and require external memory and timers. Microcontroller consume less power uh, and use hardware architecture make them perfect for embedded system tasks. Now look at the star of this presentation, micro-oven simulation. Microwave oven is an electric oven that heats and cooks food by subjecting it to electromagnetic waves. The microwaves are absorbed by water, fat, sugar, and certain other molecules whose constant vibration produce heat. The heat thus occurs inside food without warming the surrounding air, which greatly reduces cooking time. In this project, we implemented four modes for microwave oven. First, micro mode. In this mode, food is cooked traditionally. It uses maximum power of 900 watt and maximum time that we can set is 60 minutes. Second, grill mode. This mode is simply used for grilling. There is another grill heater placed inside a specific location that can be provide the grill effect. Convection mode. In this mode, the heater is turned on and the fan is provided within chamber, the microwave chamber that circulate air throughout the chamber to give that baking effect to item placed inside. Fourth, start mode. This mode is used to switch on microwave. By default, time will be 30 seconds. To, implement to implement this project we use or require MPLAB XIDE for coding, XC8 for compiling code, and PixSimLab to simulate hardware. In PixSimLab simulator, we use PixGenius board, especially PIC16 at F877 microcontroller, CLCD, tactile switches, and matrix keypad, timer, interrupters, and so on. Then we see PIC our microcontroller PIC16 F877A, which is popular 8-bit microcontroller known for its versatile, low cost, and range of integrated peripherals, making it widely used in embedded systems. Key features of microcontroller. Non-versatile memory, built-in EEPROM allows for permanent storage of critical data even power is removed. Low power consumption, designed to operate efficiently in low power mode, make it suitable for battery operator. Integrated peripheral include an analog to digital converter ATC, timers, and communicational interference reduce the need of external components. Now this is architecture of PIC16F877A. CLCD means character liquid crystal display, which is most basic form of electronic display device which is widely used. The main advantage of using CLCD instead of 7-segment display and other multi-segment LEDs is that there are no limitation in displaying special and custom characters, animation, and so on. Most importantly, the module can be interfaced by easy, unlike other modules with no complexity in both hardware and software. In PC Lab Simulator, there are two types of display, 16 by 2 display and 16 by 4 display. Tactile switch. Tactile switch is switch whose operation is perceptible by touch. This switch used to select mode of operation and the enter temperature and to enter time in our project. This switch will produce bouncing effect when switch is pressed. Matrix keypad. This keypad is which number of tactile switches connected in rows and column concept. This used in more number of user input are required and still want to save some controller. This keypad are most commonly used in telephone, calculator, digital locker, etc. From key 1 to 4, we select mode operation. From and also 1 to 9, we set time or temperature. Key star for clearing and key hashtag for entering. Timer. Timer is one of the important application in an embedded system, which is default peripheral which maintain the timing of operation in sync with system and an external clock. It is many applications such as measuring time and generating delays. Timer oblique counter is software designed to count the time interval between events. Tick is referred as the change from one number to another number. It may be up count or down count. Here, the Timer block diagram is also shown. Interrupts. Interrupt is communication process set between microprocessor and microcontroller in which an internal and external device request MPU and MCU to stop the processing. MPU CU acknowledge the request to attend to the request. Go go back the processing where it not interrupt. For example, if the oven door is open while cooking, an interrupt triggers the ISR to stop the machine immediately. Then what is ISR? ISR is interrupt service routine, and ISR is a software routine that hardware encodes in response to an interrupt. ISR attend to request of interrupting source by clearing the interrupt flag and should save register content that may affect by code in ISR. When interrupt occurs, the MPU completes the instruction, then begin executed, then it disable goal interrupt enable, place the address from the program counter on the stack. Now enough theory. Let's go the demo of my project in Pixim Lab. First, we have to see where we have written the code. This is MPLAB XIDE version 6.25 where we have written the code for my project of Microoven simulation. First, we have to open our project. This is where I save my project in desktop. Open Microoven project is opening as you can see. As you can see that our project is open. In project there are two important folders where header files and source file are stored. In source file you can see CLCD, ISR, main, matrix keypad, Microoven timers. And same as in header CLCD, main, matrix keypad, oven and timer. In source file we save main where we have written our code for our project as you can see in this. Then in Microoven also they are they all see extension files. Then we have to first compile our project so clean and build it. As you see, time take for cleaning and building. This you can see our project is clean first and then build successfully. Now we have to load this file or project in Pixim Lab Simulator. This how our Pixim Lab Simulator looks. First we have to select our board PixGenius, then microcontroller PIC16F877A, then select CLCD size 16 into 4, and this how our board is looked. Here you can see a CLCD display, matrix keypad, LEDs, EEPROM, main are microcontroller PIC16F877A, then fan for cooling, heater, relays, and reset button also. Now then load our project. Now project is loaded. Then we have to select our microcode, our operation mode first. Now select micro mode. Here you can see we have to set a time. We will set time of 50 seconds and enter. As you see, we have entered and time countdown is started. As you see three options, if you press 4, it resume or start. Means we have to press 5 for pause it and press 6 for stop it. As you see, I press 5, then it stop, and also then I press 4 for resume. As you see, time is up and you enjoy your meal. Now we have to select second mode, green mode. Now same as in micro mode, we have to set a time. Here we set 50 seconds as same in micro mode and enter. Same similar options. Last 20 seconds is remaining for grilling effect. Last 10 seconds. 5, 4, 3, 2, 1, and time up and enjoy your meal. Then convection mode 3. First we have to set a temperature. I set 60 degree and enter. It takes preheating time of 1 minute 60 seconds, approximately 60 seconds. Waiting pre- As you see, 5 second remaining for preheating. As similarly, we have to set time for convection mode. As I said, similar time 50 seconds. Now enter time countdown is started. The similar option as in about two modes. Time ups and enjoy your meal. Now select food mode or last mode, start mode. As default time 30 seconds and similar option as same as above three modes. Time ups and enjoy your meal. This how we have first written our code in PiximLab, MPLab simulator, MPLab XIDE, then simulate that code in PixGenius board in PiximLab simulator, and conclude conclusion. Now let's move on conclusion of this internship. Conclusion means what I gain or from this internship, I gain a knowledge about the internal working of embedded system, hand-on programming and domain skill introduced to different software along with interfacing, real-time experiment and good exposure in industrial standard practice of software development. In last, thank you for Emotsi for giving such wonderful and quality learning internship program. Thank you.